All right, students, welcome back. Like I told you, we are going to go hard from now until we get ready to take those state tests. So I want you to buckle down. You really have an opportunity right now to turn your year around. If you've been waiting, now is the time. If you've been doing what you're supposed to do, you want to also keep your foot on the gas. You guys have done a really good job of paying attention when I've told you in the past when I say, hey, kids have a lot of trouble with this, so make sure you pay attention. You guys have really risen to the challenge every time I've told you that. You've paid attention, and today should be no different. So I really want you to pay attention because these concepts can be difficult if you miss these early lessons. All right, so, and I waited until after spring break so that I didn't have to break this up so that you give it all at once. So now you have a good chance to rest. We had an easy last week before we left, and now you've had break. So I want you to focus right now. Anytime that anybody's trying to distract you or anything like that, you make sure you ignore them and you stay focused and you handle your business, because somebody's probably going to try to talk to you or be disruptive around you, but you stay focused. All right. Now, density. Okay. By definition, density is the mass per unit volume of a material. So that's the simple definition, but what does that really mean? So let's break this down. Okay, first of all, I want you to remember that mass, okay, is the amount of matter in an object, okay, or in a substance. I'm gonna just say material, the amount of matter that's in a material. So for example, remember we get the mass of an object by putting it on a scale or a balance. Okay, if you put a brick on a balance or you put a feather on a balance, the brick is going to have more mass because there is more matter in that brick. And obviously it depends on the amount that you have, but remember that mass is the amount of matter that's in a material. Okay, so the more matter it is, the more massive it is, or how big it is. Now, volume, you should remember, is the amount of space a material takes up. Okay, so like for example, in a 2-liter bottle, it holds a volume of 2 liters, okay, because that's how much space is in that bottle. So, but density is the mass per unit volume of a substance. So what it's really telling us, okay, and there's another way to write that, and you're going to see this: density is equal to the mass per volume of a substance. And so you can see that that's also like a division problem. You take the mass of an object divided by the volume, and that gives you that object's density. Density is equal to the mass divided by the volume. Okay, but what this is really telling you is that density, it's how much matter is in a certain amount of space. So the mass per unit volume, in plain English, is telling us it's how much matter is in a certain amount of space. Okay, so it's how much matter that's in a certain amount of space. Okay, right now, I mean, you're going to see this in a minute. Say, if you may have written this down if you're a really good student. If you haven't written it down, no big deal. But I just wanted to break it down for you for right now. So density tells us how much matter is in a certain amount of space. And so let me break this down for you. Okay, every substance has a certain amount or a certain density. Okay, and let me come back up here and write this again. So density equals mass, okay, divided by the volume. So the mass, the amount of matter we have in the space. Now the units we use for mass is grams, and the units we use for volume, well, this is going to be different. Okay, it's going to be centimeters cubed. Okay, but that's for a solid if you're looking for the volume of a solid, or it might be milliliters. Okay, and that's if you're looking for a liquid or the volume of a liquid. We measure the volume of a solid in centimeters cubed, that's a 3, or milliliters. which is for liquid. So your answers for your units for density will be either in grams per centimeter cubed when you figure it out, because grams on the top per centimeter, or it will be in grams per milliliter. Okay, again, this is if you are looking for a solid, and this is if you were looking for a liquid. Okay, so that's our basic formula. Now, every object has a specific density. So for example, the density of water is 1 gram per milliliter. Okay, because water is a liquid, or it could be a solid. If it was a, if it was ice, we would do density would change because liquid water is 1 gram per milliliter. Okay, but no matter what, if you have a tiny amount of water or you have a swimming pool full of water, it doesn't matter. If it's H2O, this is going to be the density. So I want to break this down for you. Okay, so we've already gone over these 2 pages in the book. If you're on page 130 and 131, okay, hopefully I've already told you to turn to that. That's what we've told you here. Okay, and it's also telling you right here that each substance has a specific density. So for example, silver has a density of 10.5 grams per centimeter cubed. Again, it used grams per centimeter cubed instead of grams per milliliter because this is a solid. Okay, and so, but no matter what size or amount of silver you have, the density is always going to be 10.5 grams per centimeter, because, and actually you're going to see this in a second right here. Okay, it doesn't matter how much you have. So look, for example, let's say here we have a chocolate bar, and we have the mass of the chocolate bar is 226 grams, and it takes up a volume of 190 centimeters cubed. Well, density is the mass divided by the volume. So if you do 266 divided by 190, you're going to get 1.2 grams per centimeter cubed. So we've calculated here that the mass of this piece of chocolate is 1.2 centimeters or grams per centimeter cubed. But what about over here? If you look at this little piece of chocolate, it has a smaller mass because it's smaller. So its mass is only 113 grams. But then if you see, it's also going to take up much less space. So this piece of chocolate takes up a space of 95 centimeters cubed. But still, if you do 113 divided by 95, which is the mass divided by the volume, you see that you get the same density. Because just like if you have a little bit of water or a lot of water or a little bit of silver or a lot of silver, the density doesn't change. The density of all chocolate, or at least this type of chocolate, is always going to be 1.2 grams per centimeter cubed. Okay, so because it's still made of the same stuff. So this chocolate is made as the same as this little piece of chocolate. So the thing is, when you work out the density, it still comes out to the same thing. So you need to be careful of that. And because they divided this in half, that chocolate has the same mass, which is 113, the same volume, and you work it out and you get 1.2 grams per centimeter cubed. So you see here that the amount of matter you have does not affect the density. Okay, so you need to keep that in mind. All right, because if it's made of the same stuff, it's all good. So here, let me show you an example. Now, this is the density of some common materials. You see this on page 135. Let's look right here. Remember, I told you that density is the amount of matter that's in a certain amount of space. So you see that each one of these boxes here is the same size. Okay, so they take up the same amount of space. But you notice that in this one, it's got more stuff in the same amount of space. So it's how much matter is in a certain amount of space. Remember, we said that earlier. It's how much matter is in a certain amount of space. You see that there's more matter here than there is here, and more matter here than there is here. So we could say that this material, whatever it might be, is more dense than this material, and this material is more dense than this material, because this material in a certain amount of space has more stuff in it than these two. Like, think about this classroom right now. All right, the classroom can't change size because it's got the 4 walls and the ceiling and the floor. So there's a certain amount of us in here right now. So we could say that we have a certain density of students in this classroom. Now, if more and more people came into the classroom is not going to change size, but we'd have more people in the same amount of space. It'd be more crowded. Okay, so if it's more crowded, then the room would be much more dense because we'd have more people in the same amount of space. And if people left the classroom, the classroom will be less dense. But look right here, this just highlights the point we were making. Specific substances, they're kind of like fingerprints. They have very specific densities. The density of water, as I already told you, is 1 gram per centimeter cubed. Okay, but the density of gasoline, for example, is less than 1. It's 0.74. Okay, so whether you have 1 drop of gasoline or a whole gallon of gasoline, the density is still going to be 0.74. Okay, and then they list some other substances here in their specific densities. And sometimes density can help you identify what an object is. Let's say you had a glass of water and you had a glass of pure gasoline. And looking at them, you can't tell the difference because they're both clear. And let's say you weren't going to smell them or set them on fire or anything like that. But if you were just looking at them, you could calculate the density of each one. And if you found that, you calculate the density of one substance and it was 0.74, well, you know that would be your gasoline. All right. So how do we measure density? Well, there's a few ways. Okay, well, we already know if density is equal to the mass divided by the volume. Let me rewrite this. Okay, if density is equal to mass times the volume, you see we have another 3-variable equation here. So we could use our triangle depending on what they ask us for. Density equals mass divided by volume. Okay, so it's another 3-variable equation. But simply, you take the mass of an object and then you divide it by the volume. And that'll give you the object's density. Okay, remember the instrument that we use to measure mass would be a scale, okay, or a balance. So you put it on the balance and you see what the mass is. Now, volume. We calculate volume in different ways, okay? For liquids, okay, we use a graduated cylinder. And that's going to give us our answer in milliliters, okay? You remember what a graduated cylinder is. It's a tall tube that we pour liquids in, okay? Or if it's a solid, well, it depends, okay? And this is where we're going to talk about later, okay? So if it's a solid, you have 2 options. If it's a rectangular object like this, we get the volume by doing the length times the width times the height, okay? And so that would give you the volume. So if you took the mass of an object and let's say you found it to be 25 grams, okay? And then you found, let's say it was a solid object like this, and then you found it to be 5 centimeters cubed. Okay, so let's say you did, it was 5 centimeters long, okay, times 1 millimeter wide or centimeter wide times 1 centimeter high. 5 times 1 times 1, well, that's 5. So the volume will be, that'd be 5 centimeters times 1 centimeter times another centimeter. Okay, 5 times 1 times 1 is 5. Centimeters times centimeters times centimeters is centimeters cubed. So that would be your your volume over here. Okay, and that would be your density. So your density would be equal to 25 divided by 5 would be 5 grams per centimeter cubed. All right, so that's how you find the density. But what if, what if you want to find the object of, say, something that wasn't a square? Okay, let's say you have a rock, okay, and it's shaped, that's bad. Okay, so let's say it's shaped, a rock like this. All right, now obviously there's all these curves and stuff, so you can't do, length times width times height because there's no length, there's no width, there's no height. Okay, so to find the volume of an object that's irregular like this, we use what's called the displacement method. And this is how it works. You get in the bathtub, and then if the bathtub's super full and you get in it, the water comes up and the water overflows. That's because you are displacing water that used to be in there. So for example, let's say you do the displacement method. Let's say I had a graduated cylinder, or an object, and let's say it's got water in it, and let's say it has 50 milliliters of water in it. Okay, remember, we're trying to find the volume of this rock. So if you put this rock in here, it's going to make the water level rise. And let's say the water level rises up to, I don't know, let's say it's 58 milliliters. So you put the rock in there and then it makes the water go up. Well, what's the difference between 50 and 58? Well, you see, this rock made the water level go up 8 milliliters. So the difference between the starting volume and the ending volume must be the volume of what you put in there. So the rock must have a volume of 8 milliliters. But remember that solids we use centimeters cubed. And you should know right now that 1 milliliter is equal to 1 centimeter cubed. And so 8 centimeters or 8 milliliters is also equal to 8 centimeters cubed since it's a solid. So the volume of our rock would be 8 centimeters cubed. So that's how you take the volume of an irregular solid. Use the displacement method. You're going to see this again. Now let's say, for example, that we had taken the mass of this rock and we found it to be 16 grams. Okay, and we wanted to know the density. Well, again, density is equal to mass divided by the volume. So that would be 16 grams divided by 8 centimeters cubed. Okay, so 16 divided by 8, you know that that's 2. So our answer would be 2 grams per centimeter cubed. Now, I know that was a quick crash course, okay, but that's the basics of it, and that's the mini lesson for this lesson. You're going to get to see this again. I'm going to upload this to the Facebook page, so make sure you check that out. We're going to be using the Facebook page a lot more because I'm going to be going quickly and people might need to see stuff again. So make sure you watch this again if you need to, and get to work. You don't want to get behind. Stay on top of it. You do everything you're supposed to do. You're going to be just fine. Okay, if you want to do better, don't talk about it, be about it.